trigonometric parametric or polar parametric form. So here in this one, so what I do is see in this one. So first, suppose this is x-axis and one line which is making an angle theta with the positive direction of x-axis. On this line, you take one fixed point, that is some a h comma k is a fixed point, and q x comma y is a variable point. Now the distance between the fixed point and variable point is some small r, and this is the angle made by the line with the positive direction of x-axis. So here, for a given straight line, theta is fixed. Theta is a constant for a given straight line. For one line, one theta will be there, only slope. That's why theta is fixed here. A h comma k is a fixed point. This is some 2 comma 3 4 comma 5 like that, given point. This q x comma y is a variable point. So q x comma y is a variable point means r is also variable. R is a parameter. As r changes, q x comma y changes. For different values of r, different point, variable point, you will get. That's why q x comma y is a variable point. Now what you do is, from a h comma k, you drop the perpendicular on x-axis. So this is x-axis. So if you drop the perpendicular, this is the perpendicular. Now from q x comma y also you drop the perpendicular on x-axis. This is n. Again from a h comma k, you drop perpendicular on qn. So this is some, you call this is some r. This is r. Now suppose this one is y-axis. Suppose this is y-axis, then this one is origin. This is y-axis. Now tell me, what is OM distance? OM distance is this x coordinate of A. That is OM distance is h, and ON distance is x coordinate of q, that is x. Now MN distance equal to x minus h. Therefore AR distance is also x minus h. Similarly, this QN distance is y and NR distance is k. Therefore QR distance is y minus k. Now, so this angle is also equal to theta. Now from right triangle, now this is a right angle triangle AQR. From AQR right angle triangle, y minus k and x minus h and r, these are the lengths of the sides. Here r is the length of the hypotenuse. Now what we do is, from right triangle, so from right triangle, what is that? ARQ. From right triangle ARQ, what is sine theta? Opposite by hypotenuse, that is y minus k by r. And what is cos theta? Adjacent by hypotenuse, that is x minus h by r. So from this one, r is equal to what? Y minus k by sine theta. This is number one. From the second one, r is equals to x minus h by cos theta. This is 2. X minus h by cos theta. This one is 2. Now equate both the r's. Sir, no. So from 1 comma 2, from 1 and 2, x minus h by cos theta is equals to y minus k by sine theta is equals to r. So this is the parametric equation of the straight line. So here, what is now you will write the data, that is p x h comma a h comma k is a fixed point. So here, okay, here a h comma k. And one more thing is, before that one more thing is, how can you take any point that is b coordinates here, not b, qx comma y coordinates. So qx comma y coordinates you can take from this one, x minus h is equal to r cos theta, that is a x equal to h plus r cos theta, and y minus k is equal to r sin theta. So y is equal to k plus r sin theta. So here, actually here b coordinates are what? Now bx comma, sorry, qx comma y coordinates are what? Variable coordinates h plus r cos theta, comma k plus r sin theta. So here r is algebraic distance. So algebraic distance, what is the meaning of algebraic distance? Suppose here we have one point. So from here we moved 2 units. We moved 2 units. 2 units means you can move upward or downward. So for upward, positive 2 we use. For downward, negative 2. Distance never be negative, but to distinguish upward and downward, rightward and upward, we use the sign, negative sign. So here upward, suppose 2, downward minus 2. That's why here r is called as algebraic distance. So that's why suppose in any question, suppose from the point some 2 comma 3, we have 3 units distance. How many points are possible? 3 units distance, 2 points. One is this one, another one is this one. So here we will take upward 3 units, here downward r is equal to 3 units, upward r is equal to minus 3, downward, like this. So here r is called as algebraic distance. So here, now any point on a line, general point can be taken as what? H plus r cos theta, k plus r sin theta, or h plus r minus r cos theta, k plus r minus r sin theta. Here this is the variable point. Why it's a variable point? Here h is fixed, theta is fixed, but r is variable. That's why it's a, because of r, that's a variable point. So now we will write the data. So here a h comma k is a fixed point. Next, qx comma y is a variable point. Is a variable point, and theta is the angle made by the line with the positive direction of x-axis. Otherwise, directly we will write inclination. Theta is inclination. Inclination means the angle made by the line with the positive direction of x-axis. Theta is inclination. R is algebraic distance. R is algebraic distance. This is about parametric equation of the straight line. This is parametric equation of the straight line. So suppose, yes, now here theta for all the lines, here theta belongs to closed 0 to open pi. So here theta belongs to closed 0 to open pi. So now means theta belongs to closed 0 to open pi means tan theta, what is the here inclination? Inclination is what? Theta. Therefore tan theta is what? First, here theta belongs to 0 to pi means first quadrant and second quadrant. Yes or no? Here we include 0, that's why here exclude pi. Yes or no? Therefore first and second quadrant. In first quadrant tan theta is what? Positive. In second quadrant tan theta is what? Negative. Here tan theta positive in first quadrant, second quadrant tan theta is negative. Therefore, so sin theta is what? In parametric equation of the straight line, whenever the question is a parametric equation, then we need to use cos theta, sin thetas. That's why tan theta, suppose tan theta is positive, then sin and cos both are positive, because tan theta will be positive in first quadrant. First quadrant sin cos both are positive. Suppose tan theta is negative, then sin theta is always positive because first and second quadrant only. That's why sin theta positive, cos theta is what? Negative. Just if tan theta is positive, you write the values for sin and cos both positive. If tan theta is negative, for sin you write the positive value, but for cos negative value. You memorize this one. So here theta belongs to 0 to pi. So solution. See now, so this is the given line is what? L is equal to 2x minus 5 plus 3 equal to 0. Now tell me, what is the slope of this line? That is tan theta is equal to minus 2 by minus 5, minus a by b. This ax plus by plus c equal to 0 line slope is what? Minus of a by b. This is so. Here minus 2 by minus 5. That is equals to what? 2 by 5. So 2 by 5 is what? Positive. Means the line makes an acute angle with the positive direction of x-axis or not?
Yes.
The line makes an
Yes.
acute angle with the positive direction of x-axis. Therefore, line will be like this. Orientation of the line. So this is x-axis. So this is the given line. Now, what is our requirement? So now what is our requirement? We need to find, this is x-axis. This is the given line. That is what? 2x minus 5y plus 3 equal to 0. Now on this line, one fixed point is given, a1 comma 1. a1 comma 1, does it lie on this line or not? Yes. If you substitute 1 comma 1, 2 plus 3, 5 minus 5. So this point a1 comma 1 lies on this line. Now what is the question? We need to find the 2 points on this line. One is 2 units above the fixed point. Another one is 6 units below the fixed point. So suppose this is 2 units above, means we take R is what? Positive. Yes or no? R is positive.
Yes.
Suppose these are the
Yes.
A, this is P point. We need to calculate. So this is how many units? 2 units above, that's why positive. Here R is positive. Now below, how much distance is what? Below distance 6 units,
6.
somewhere over here.
6.
These are not exact locations. Okay, so just a rough diagram only. Okay, so need not to draw the fair diagram, exact diagram. Therefore this is some q coordinates. So this distance is what? Here 6 units. So 6 means here what you need to take R is equal to minus 6. Yes or no? Here R is equal to 2 for px comma y. For qx comma y, R is equals to what? Minus 6. Now directly, suppose this is the angle theta. Directly we use that variable point coordinates. Otherwise, we will solve this question. This is the first question. That's why first what we do is tan theta already we calculated. So tan theta is equals to what? 2 by 5. So tan theta 2 by 5 means, yes, this is theta. This is 2, 5. So what is this? This one, tell me. 25 plus 4. That is 29, square root 29. So from this one, we need to write sin theta. What I said, suppose tan theta is positive, then sin theta, cos theta both are positive. Therefore, you need not to bother about the sign here. Sin theta is what? 2 by root 29. So cos theta is equal to what? 5 by root 29. So sin theta is always positive, whatever the theta might be. Tan theta negative or positive, sin theta just blindly you write plus. But cos theta sign depends on tan theta sign. Tan theta is positive, cos theta positive. Tan theta is negative, cos theta is negative. Because second quadrant cos is negative. So now here sin theta, cos theta both are positive. Both are positive. Now we will write the coordinates of P and Q. Now for px comma y. So for px comma y, r is equal to what? 2 units. R is equal to 2 units. Therefore, px comma y coordinates, how can you write? Is equal to h plus r cos theta. H is what? Fixed point. This is h comma k. Fixed point coordinates. H plus r cos theta. R is 2. What is cos theta? 5 by root 29. Comma k plus r sin theta. So k is also 1 here. R is 2. Sin theta is 2 by root 29. So p coordinates are what? 1 plus 10 by root 29, comma 1 plus 4 by root 29. So these are the coordinates of p. Next, for qx comma y, r is equal to what? It's below, relatively downward. Therefore, r is equal to minus 6. Therefore, qx comma y is equals to 1 plus of minus 6 into cos theta, that is 5 by root 29, comma 1 plus minus 6 into sin theta, that is 2 by root 29. That is qx comma y coordinates are 1 minus 30 by root 29 minus 1 minus 12 by root 29. So these are the coordinates.